Hi guys, it's day 2 of solving trigonometric equations. The first page of these notes are very similar to what you did last time. It just has some secants, cosecants, and tangents in there. And then the second page is going to be a little bit different. The rules really don't change. There's no blanks to fill in today. We're just going to get after it. On example A, we are using substitution to determine whether the given x value is a solution. So you're going to substitute 5/3 pi in for x. So you have the secant of 5/3 pi minus 2 equals 0. And now you're going to go to your unit circle. And we know that the cosine of 5/3 pi is 1/2. So the secant of 5/3 pi is the reciprocal of that, which is 2. And 2 minus 2 does equal 0. Since this works, we can say yes, 5/3 pi is a solution. You can just say yes or no. You don't have to write out the whole sentence. But keep in mind that when you're solving any of these equations on the rest of your notes, you could use this method to check your answers. I'm not going to take the time to check the answers for each individual problem, but that is possible. Remember, your main goal when solving a trig equation is to isolate the trig function. On example B, we can, since we only have cosecants in our problem, we can start the problem by factoring out a cosecant squared of x, which leaves us with cosecant squared of x minus 4 equals 0. If this was algebra 2 and you had x squared minus 4 equals 0, you would factor that again because it's a difference of two perfect squares, and you would factor that into cosecant of x plus 2 and cosecant of x minus 2. Now you can set each factor equal to 0. So we get cosecant squared of x equals 0, cosecant of x plus 2 equals 0, and cosecant of x minus 2 equals 0. If I take the square root of both sides here, then I get cosecant of x equals 0. Remember, cosecant is the reciprocal of sine, and the reciprocal of 0 is undefined, so this means that sine of x is undefined. There's no spot on our unit circle where the sine or the y value is undefined, so we have no solution for this part. We can just ignore that. Moving on to the next one, I would subtract 2 from both sides, and I'd get cosecant of x equals negative 2, which means the sine of x equals negative 1/2, and I'd get cosecant of x equals positive 2 here, so the sine of x equals positive 1/2. Well, sine is equal to 1/2 at all of our sixths. So since we can equal positive 1/2 and negative 1/2, we are going to include all of our solutions. But we got to look at our directions up here, and it just says find all the solutions. It does not say on the interval 0 to 2 pi. So that's where we have to include the 2n pi in our answers. So I'm going to write pi over 6 plus 2n pi. I'm going to include 5/6 pi plus 2n pi. I'm going to include 7/6 pi plus 2n pi. And I'm going to include 11/6 pi plus 2n pi. These answers apply for both of these. I really didn't go in take into consideration each one individually. Since sine is negative 1/2 here and positive 1/2 here, I knew I was going to be in all 4 quadrants. So I went ahead and listed the 6th in all of those quadrants. If I really wanted to get technical with the way I wrote my answers, these two should be switched, because 7/6 pi goes with negative 1/2 and pi over 6 goes with positive 1/2. Again, it really doesn't matter because you needed all 4 quadrants answers. So as long as you have all 4 of those answers, you're good. Moving on to example B. If I want to isolate the trig function, I would subtract radical 3, and I'd get tangent is equal to negative radical 3. Well, tangent's negative in quadrants 2 and 4, and it's negative radical 3 at 2/3 pi and at 5/3 pi. We're going to add 2 pi to our answer because of the directions again. The only time you do include the plus 2 pi in your answers is if it says find all the solutions of each equation. You may have noticed that in the back of the book when you're checking your answers, sometimes it adds 2 pi and sometimes it just adds n pi. Before I do examples D and E, I want you to understand what that means. If you're at this spot on the circle, which is pi over 4, and you add 2 pi to it, that's going to take you around to that spot again. If you're at this spot on the unit circle, which is pi over 4, and you just add n pi to it, that's going to take you halfway around to this spot on the circle. So you can write the answers in different ways, and depending on where you need to end up on the circle, you can either add this or this to your answer. I just go ahead and always add 2 pi to make my life easier because I know one revolution around the circle is going to give me back to that same spot. Okay, now let me delete this and let's go on to our next example. Our next example is already factored for us and the directions are changing again. We only want our solutions to be on the interval 0 to 2 pi. So what this means is we do not have to include the plus 2 pi in our answers. When your problem starts out already factored, you can go straight to setting each factor equal to 0. And solving for tangent squared. So I would add 1 and divide by 3. Take the square root of both sides. Remember, when you take the square root of both sides, you have to include plus or minus in your answer. And this is what we end up with. Since we have plus or minus in our answer, that's going to put us in all 4 quadrants. Tangent is equal to 1 over radical 3 at the 6th. So we have pi over 6, 5/6 pi, 7/6 pi, and 11/6 pi as our 4 answers for that part. The next one's very similar. We're going to isolate the tangent squared. We're going to take the square root of both sides. Since we took the square root of both sides, we're going to include plus or minus in our answer again. And tangent is equal to positive radical 3 and negative radical 3 at my thirds. So I'm going to list all of my thirds. I am not including the 2 pi because of the directions. So once I get that list made, I have my solutions. So I actually have 8 solutions for this problem. All the problems I've done so far have been just an x value for the angle, tangent of x, sine of x, cos of x. At the top of your paper, you see another rule that says to solve equations that involve trig functions of multiple angles, that's what we have here with a 3, that means we have to first solve the equation for 3x and then divide our result by k, which in this problem would be 3. So I'm going to ignore that 3 in front of the x, and I'm going to go ahead and solve this problem as if it were just tangent squared equals 3x, or tangent squared equals x, sorry. So I'm going to take the square root of both sides, which gives me the tangent of 3x equals plus or minus, because I took the square root, radical 3. This is very similar to what I just did right here. So if I am ignoring the 3 in front of the x right now, I know that tangent of x equals plus or minus radical 3 at all my thirds again. So I'm going to separate this into 4 areas so I can work. Because instead of writing my answer like I did in example D, I'm going to write 3x equals pi over 3, 3x equals 2/3 pi, 3x equals 4/3 pi, and 3x equals 5/3 pi. In the last example, it was just an x for the angle, so I could go ahead and just write x equals and I can list all my answers. But since I have a 3 in front of the x, what that means for me is that I'm going to have multiple answers because I have a multiple angle. These are probably the hardest problems to understand of all of the solving equations, so we'll do a couple of these in the notes today. Because I need to get multiple answers, I need to add to each one of these equations pi. The reason why I'm adding pi is because pi is the period for tangent. So if this was a sine or cosine problem, I would be adding 2 pi. But since it's a tangent problem, I only add pi. Now I have to solve for x, which means I have to divide this by 3. But in our world of math, if you divide one thing by 3, you have to divide all things by 3. So that gives us, for our final answer so far, x equals pi over 3 divided by 3 is pi over 9 plus pi over 3. If you want to figure out quickly what your denominator will be when you do this right here, all you have to do is multiply these two things together, and that gives you the 9 on the bottom. So if I do this to each individual problem, so I'm going to divide this by 3, divide this by 3, and so on. Then that gives me, for an answer over here, x equals, remember, multiply these together, so 2 pi over 9 plus pi over 3. The 3's are going to cancel with all of these. X equals 4 pi over 9 plus pi over 3. And x equals 5 pi over 9 plus pi over 3. I can't leave my answers like this, though, because my directions say find or write all the solutions on the interval 0 to 2 pi. So I got to go back up here, and I have to realize that this is one of my solutions, this is one of my solutions, so is this, and so is this. But that's not all of my solutions. I have to add pi over 3 to each one of those. So what I'm going to have to do is I'm going to have to make a list of all of my answers. I had to erase and kind of give myself some more room here, but this is where we left off. We had these 4 answers, but now what you have to do is you have to make a list of all of your answers. I'm going to start with pi over 9, but then I have to add pi over 3 to it, which means I need to get a common denominator. So if I get a common denominator, I'm really adding 3 pi over 9 to all of these. So I'm going to list my answers over here. So if I add 3/9 pi to 1/9 pi, then that's going to give me 4/9 pi, which I already knew that was one of my answers. If I add 4/9 pi and 3/9 pi, that's going to give me 7/9 pi. 7/9 pi plus 3/9 pi is 10/9 pi. 10 pi over 9 plus 3 pi over 9 is 13 pi over 9. 13 pi over 9 plus 3 pi over 9 is 16 pi over 9. And now I got to stop and ask myself, just how far do I go? Well, the answer is this. You can only go to 2 pi. So you have to ask yourself, how many ninths is equal to 2 pi? And in this case, is 18. So your numerator cannot go over 18. In order to get this quickly, you can always just take your denominator, multiply it by 2, and your numerator cannot go over that number. So I have to stop there because if I add another 3/9 pi, that puts me at 19/9 pi, and that's over 18/9 pi. I've already included this answer, so now I'm going to go to 2/9 pi. And I have to start adding 3/9 pi to that. So 2/9 plus 3/9 is 5/9. So that means that answer is taken care of. 5/9 plus 3/9 is 8/9. 8/9 plus 3/9 is 11/9. 11/9 pi plus 3/9 pi is 14/9 pi. And 14/9 pi plus 3/9 pi is 17 pi over 9. And I stop there. That's all my answers I can get. I've already included this answer. And I've already included this answer of 5/9 pi in my list. So I don't have to continue. I am done. If I have a multiple angle, that means I'm going to have multiple answers. These are the fun ones. Let's go back to letter H. I'm sorry. Let's go to letter F now. And our answers are still on the interval 0 to 2 pi. So again, we want to isolate the trig function, which means we're going to add 1 to both sides. We're going to take the square root of both sides, and we get secant of x equals plus or minus 1. Whenever you take the square root of both sides, you need to make sure that you are including the plus or minus in your answer. If secant equals plus or minus 1, then cosine is the reciprocal of secant, and the reciprocal of 1 is just 1. So where does cosine equal positive 1? Well, that's going to be at 0 and at 2 pi. Where does cosine equal negative 1? And that's at 1 pi. Remember, you got to think about your answers before you move on. Our directions will not allow us to include 2 pi in our answer, so we have to eliminate that. 2 pi has the parenthesis, which means we cannot include it. So moving over here to G, on G we are going to have to set this equal to 0. So we need to subtract 2 cosecant first. So you get secant of x, cosecant of x, minus 2 cosecant of x equals 0. If you don't know where to start, set your equation equal to 0 and see what you can do algebraically. I can factor out a cosecant, which leaves me with secant of x minus 2. Once I get it factored, I can set each factor equal to 0. So I get secant of x equals 2, which means cosine of x equals 1/2. And over here, if cosecant of x equals 0, then that means sine of x is undefined. Well, we've already said earlier in the notes that a y value is never undefined on the unit circle, so we have no solution for this part. And moving over here, cosine is equal to 1/2 at 1/3 pi and at 5/3 pi. With example H, we need to treat this like an algebraic equation, which is a trinomial, and that factors. That factors into 2 sine of x and 1 sine of x. And then the factors of 1 that we're going to use are just 1 and 1. Once I get it factored, I can set each factor equal to 0. And here, sine of x would equal negative 1/2. When I set this factor equal to 0, I'd get sine of x equals negative 1. Sine of x equals negative 1/2 at 7/6 pi and 11/6 pi on our unit circle. And sine, or the y value, is equal to negative 1 at 3/2 pi. So I have 3 answers here. These last couple, we're going to get into some special cases. If you notice, the x is divided by 2 on example I, and the x has a 3 with example J. So both of these have a multiple in front of the angle. You're multiplying the angle by 1/2 or by 3. So again, what I'm going to do when this happens is I'm going to ignore the x over 2 right now, and I'm going to treat this just like it's sine of x equals negative radical 3 over 2. I know that sine is negative in quadrants 3 and 4, and it's negative radical 3 over 2 at 4/3 pi and at 5/3 pi. But instead of writing x equals, I have to write x over 2 equals. Since I have a multiple with my angle, this is the only time when you have directions, find the solutions on the interval 0 to 2 pi, that you have to add either a 2 pi or a 1 pi to get your multiple answers. Notice I'm not putting the n with this. The n is not included because I'm only going to 2 pi. So in this particular problem, what I'm going to do to solve for x is I'm going to multiply everything by 2. That cancels the 2 off of the x, and what it does over here once I distribute is it gives me x equals 8 pi over 3 plus 4 pi, and x equals 10 pi over 3 plus 4 pi. When you have your multiple answers, you're always going to start with these answers and go from there. So those answers are what you look at first. Well, if you look at both of those answers are bigger than 2 pi. Because if our denominator is 3, then 2 pi equals 6/3 pi. Both of those answers are bigger than 6/3 pi. So what this means is we have no solution on the interval 0 to 2 pi. We had a solution. It just did not fit our directions. So that's a special case that doesn't always happen. Moving on to the last problem. In the last problem, we have a 3 in front of the x. So you're going to ignore the 3 right now, and you're going to say, where does the cosine equal negative radical 3 over 2 on my unit circle? But instead of writing x equals, you're going to write 3x equals. Well, that happens at 5/6 pi and at 7/6 pi. Since this is a cosine problem and we need to find multiple angles, we need to add 2 pi to this when we solve our equation to find our multiple answers. If it's cosine or sine, you add 2 pi because that's one revolution. If it's tangent, you add 1 pi. So now to solve this problem, we're going to divide everything by 3. Which gives us x equals 5 pi. The numerator always stays the same. Multiply those two together and you get over 18 plus 2/3 pi. 5 pi over 18 is going to be one of your answers. And over here you get 7 pi over 18 plus 2/3 pi. And 7 pi over 18 is going to be one of your answers. So now you have to write your list of answers. So I always start with the first one. So my list of answers is going to start with 5 pi over 18, but now I need to add 2/3 pi to that. Well, remember, you have to add fractions, you have to have common denominators, so 2/3 pi is equal to what over 18? Well, you'd multiply top and bottom by 6, and you'd get 12 pi over 18. So we need to add 12 pi to our numerator. 15 pi plus 12 pi is 17 pi over 18. 17 pi plus 12 pi is 29 pi over 18. Since 18 is our denominator, if we took 18 times 2, because you're adding 2 pi and you can't go over 2 pi in your directions, 18 times 2 is 36. your numerator has to stay below 36 pi. So if I added another 12 to 29, that's over 36. So I'm done with that set of answers. So now I start with 7 pi over 18, and I add 12 pi over 18 to it. 7 pi plus 12 pi is 19 pi over 18, and 19 pi over 18 is 31 pi over 18. I'm done, because if I go any further, if I added another 12 to 31, that puts me over the 36, and my numerator cannot go over 36. Pause me, rewind me, play me back as much as you need to. This is good stuff. I know you all love it.